Roads don't just take you places, they shape the way you get there. Good day, Sir Audie. Good day, classmates. Today, we will be exploring the essential process of constructing the roadbed, an integral foundation for ensuring the stability, durability, and safety of our roadways. So, we will be discussing about the soil structure, types of base course, treated base course, grading maintenance of untreated surface, DPWH standard specifications on aggregate sub-base course, clearing and grubbing, excavation, freehaul, overhaul, construction of fields and embankment, subgrade preparation, and compaction and stabilization. So first, we will be discussing about soil as structure. Early road constructions have concentrated mainly on the road surface pavement. Little attention was given to the subgrade, the base materials, and the manner of construction, more particularly the placing and compacting of the pavement foundation. As a result, too many road failures, past and present, were recorded with an endless maintenance and rehabilitation activities. Because of these very expensive undertakings, highway agencies were prompted to undertake advanced researches and studies on the properties of subgrade and soil performance under severe conditions. After a long study of the unending road failures, road agencies have established a more detailed procedure regarding the kind of materials to be used on a particular condition, type, and behavior of the soil where the road is to be constructed. So, roadway has three major structural parts, namely a subgrade or subbase, the base course, and the pavement. So, arang picture niya sa my left side. So, first we have the subgrade or subbase. It is the earth beneath the road, properly arranged and graded, compacted and stabilized. It is defined as the supporting structure on which the pavement surface and its special undercourses rest. In a cut section of a road, the subgrade is the original soil lying below the layers designated as the base and subbase materials. On field road sections, subgrade consists of the imported materials taken from nearby roadway cuts or from borrow pit. So, ang subgrade or subbase is ang ground beneath sa road nga na-compact na kag na-prepare para mag-act as a support sa road structure. So, next is ang base course. So, the base course is the materials laid on top of the subgrade consisting of crushed stone or gravel, sometimes mixed with asphalt binders. So, ang base course naman is, ginabutang naman siya sa top sang sub-base course. Kag consisted siya sang crushed stone or gravel. So, the last is the pavement. So, the pavement is the material laid over the base course consisting of asphalt concrete or Portland cement concrete. So, ang pavement naman kuno isang material nga ginabutang sa babaw sang base course. Kag ginakonsist sa kuno sang asphalt concrete or Portland cement concrete. So, for additional information, there are two main types of pavement. So, we have rigid and flexible. So, arang iya nga picture and makita din naton ang parts sang rigid kag flexible pavement. So, rigid pavement is made of concrete and has a hard and flexible structure that distributes loads over a wide area. Flexible pavement naman is made of multiple layers, usually asphalt, that can bend and flex under loads, distributing pressure through the layers. So, based sa picture, makita na natin yung rigid pavement made up of concrete na siya, o concrete slab. And then, sa flexible naman, usually ginagamit, though made up of multiple layers siya, kag usually asphalt ang ginagamit. So, meron kita video about different road components.
Highway or road is a transportation mode on which traffic moves from one place to another.
Hey guys, I'm Suleiman Khan, and in this video, we'll be learning about different road components.
Number 1, Indates subgrade. So subgrade is just like the foundation of road, or you can say the lowest part or component of road structure which bears all the load and transfer the total load through grain to grain contact. Subgrade, which is the lowest component, you can say, that's just normally constructed at least 60 centimeter above from the highest flood level of the area. Now if any cell, or you can say the natural surface level, is above the formation level, then the surface is just cut down to proposed subgrade surface, and if the natural surface level is just below the formation level, then you can say the subgrade is kept above the ground level. Subgrade is sometimes compacted with ruler, and camber, or you can say transverse slope, is also provided to drain off the surface water. Next we have subbase, and of course this layer is just constructed above the subgrade, and if subgrade has high bearing capacity, then subbase may not be required. That means when you got subgrade with high bearing capacity, then there is no need to provide subbase layer. Subbase is just provided to, you can say, prevent the rise of water, or you can say the capillary action of subsurface water toward the pavement. Subbase can be just like the filling materials, or may contain the sand, gravel, or sometimes stones. The thickness of this layer, or you can say the subbase layer, after compaction with 8 to 10 tons ruler is normally kept as 7 to 15 centimeter. And then we have the base layer, which is constructed above the subbase, and it forms like the foundation for the road surface or topping. This is just the main component of road which can be paved of cement or maybe bituminous concrete. The thickness of this layer depends upon the you can say the bearing capacity of subgrade, and then the magnitude of the applied load. And then finally we have the road surfacing or road topping, which can be of course made up of bituminous material. Like for flexible pavement, asphalt concrete is used, and in case of rigid pavement, RCC or PCC may be used. This layer, the road surfacing, or you can say the road topping, prevents the penetration of water into the base layer and saves the lower layers from the abrasion and other weathering effects of the moving vehicle. This layer also provides smooth surface for the traffic. And that's it. This is what I got. And hey, if you like these types videos, please hit that subscribe button. Press the bell icon so you never miss an update from the Engineer Boy.
So next, we will discuss about the types of base course. So base course is classified into two types. So we have the granular base course or untreated soil mixture, and the treated base course. The granular base course is a road structure of untreated soil mixture described as gravel road. So ang granular ko no, na base course, wala pa na siya na-treat, wala pa siya na-compact, wala pa siya bala na-add pa sang ibanda nga mga materials. So describe man siya as gravel road. So gravel road consists largely of stone pebbles or crushed rock particles combined with either clay, lime, iron oxide, or other fine materials sufficient enough to serve as binder of the coarse particles. So, may picture to this, next slide. So, ang sa top left side is, na siya ang untreated pa na base course. And then, sa top right side kag bottom left side is na lang na-treated na siya. Na-treat na siya. And ang sa bottom right side is gravel road. So we have the construction and maintenance requirements of untreated gravel road surface. So we have number 1, that the road must be stable to support the superimposed loads without detrimental deformation. It must be resistant against various traffic activities and could withstand the abrasive action of traffic. So, ang superimposed load ni siya, na siyang load na gina-add sa dead load, kag also known man na siya as live load, ang superimposed load. So, and is usually temporary, kag changeable. So, ang superimposed loads can include vehicle, traffic, occupants. So, based sa number 1, nga requirement na dapat ko ng road stable enough para masuportahan ang superimposed loads. Nga, para hindi mag-deform, dapat stable siya. Tapos dapat ma-resist naman ang mga various bilang ng mga traffic activities. Dapat ma-resist niya, kag ma-withstand niya ang ng mga traffic, mga gaagi ba lang ang mga salakyan sa amo na road, dapat ma-withstand niya lang kag stable siya enough para hindi mag-cause ng deformation, para wala deformation nga matabo. So next requirement is it must shed a large portion of rain that falls on the surface because water penetrating the subgrade might soften it and loosen the surface stability. So dapat ang gravel roads dapat efficiently nga ma-drain ang rainwater para ma-prevent ang pag-penetrate sang water sa subgrade. Kaya excess nga water, ma-soften niya ang mga underlying material kag ma-compromise ang surface stability, kag ma-lead na siya into structural issues. Next is, it must be free from large rocks or stones over 1 inch in diameter so that it could be regularly maintained by blading or dragging. Number 4, gravel road must possess capillarity properties sufficient enough to replace the moisture lost through the surface evaporation. The road must maintain the desired damp condition that is required to bind the particles together. Ang capillarity refers sa ability sa material nga mag-absorb, mag-retain, kag mag-transport water fluids through tiny pores or spaces. So, dapat ang gravel road ma-possess niya ang capillarity property, which means ang ability sang material nga ma-absorb, ma-retain, kag ma-transport niya lang ang water fluids sa tiny pores or spaces. Para, manabala mailisan yung moisture nga na-lost tungod sang surface evaporation. So, dapat ma-maintain man sang road ang desired nga dampness para maano niya ang required na dampness condition para ma-bind lang ang particles together. So, dapat ang gravel road may capillarity siya na properties. So, next, number 5. On dry weather, the moisture film on clay particles should bind the entire mass together. And in wet weather, the first rain that fall on the surface should expand the clay and close the pores to prevent water from entering and softening the materials. So, ang clay, plays siya sang dual role in varying weather conditions. So, pag dry ang weather its moisture film ang gabinds sa particles together, provide siya stability. So, pag wet naman ng weather, ang initial na rain, manang pa-expand sa clay, kag gina-close ng pores para ma-prevent ang pagsulod sang tubig. Kag pagis ini, mabulig naman, maintain ang integrity sa road. So, number 6. An excessive amount of highly expansive clay materials should be avoided because clay will swell and unseat the coarser materials when wet and ultimately will weaken the stability of the road. So, when we say expansive, pag-expand niya. Ang unseat na coarser materials naman ang movements ng larger particles. So, based sa requirements, ang expansive clay materials makaharm siya sa road stability. May video kita about sa answers to common questions about gravel roads.
About half of all roads in the country are unpaved. In Minnesota, local agencies are working hard to maintain 66,000 miles of gravel roads. Let's look at some of the common questions people have about gravel roads. What is a gravel road? A gravel road often is used to refer to any unpaved roadway, but a true gravel road is an engineered roadway with a surface layer constructed of aggregate, such as sand, gravel, pebbles, or crushed stone from gravel pits and quarries. Why gravel roads? The main reason for choosing to construct a gravel road usually has to do with cost. Paving a roadway with asphalt or concrete is more expensive than finishing the driving surface with gravel. Traffic volume, road network needs, and available funding sources typically factor heavily into the decision.
At least the initial costs for a paved road are very expensive, but the maintenance costs of a gravel road can be higher long-term because of the grading and the dust control factors and the re-graveling to the road, sometimes annually.
Why do gravel road conditions vary? The condition of a gravel road depends on a lot of factors. Those factors include the types of local soils beneath the road, topography, weather and climate, the available materials used to construct the road, the way the road was constructed, traffic, and maintenance practices. The quality of gravel depends greatly on composition of local supplies. The optimal gravel surfacing is a uniform mixture of stones, sand, and clay that, when compacted with adequate moisture, will form a hard crust on the road.
Most counties are doing the best they can with the aggregates that are available to them without having to go to another county or another part of the state and import what they're missing.
What does it take to keep a gravel road in the best condition? Well-maintained gravel roads are the result of a solid maintenance and improvement plan, adequate funding, good materials, good training, and good equipment. A motor grader is the primary piece of equipment used to maintain gravel roads. Road agencies use a grader to blade gravel roads as often as once or twice a week to once or twice a year, depending on the condition of the road, traffic volumes, and weather conditions.
The crown is the center of the road where it comes together and peaks in the middle. If you don't have enough crown, when it rains, water comes and it congregates just on the road and doesn't really shut off. And then over time, if it's wet in the fall, because that water isn't shedding off, you have more moisture in the road. And then when it freezes, it expands and causes more frost boils come springtime.
Roads are weakest during the spring thaw, when soils are saturated with ground moisture. To protect the investment in the road, it's important to follow weight restrictions each spring. What are common problems with gravel roads? There are several major categories of distresses that can be identified in gravel roads: poor drainage, corrugations or washboarding, dust, potholes, ruts, and loose aggregate. For the most part, these common problems depend on the specific materials used to construct the road, how they are mixed, and how they are placed to ensure proper drainage. Gravel roads need adequate moisture to sufficiently bind the materials together, especially in the protective surface layer. Without enough moisture, a gravel road will get very dusty, and the fines, which are essential for binding the surface materials, will blow away.
The big thing about controlling dust on gravel roads is to, only grade roads when you have adequate moisture, like after a rain or in the spring when there's some moisture in the road so that it seals back up.
Without enough binder, the road will washboard easily and leave a lot of loose aggregate on the road surface. In addition, slow rains will soak through the gravel, saturate the road subgrade, and make the road soft. But too much binder makes the road surface sloppy and slippery when it rains. What can you do to help maintain the gravel roads in your area?
Your local county agency or township, they're doing the best they can to keep those roads smooth and safe.
Local road users can help maintain gravel roads by simply exercising good driving habits. Help keep your gravel road in good condition by staying in your lane, traveling at an appropriate speed for the conditions, avoiding abrupt starting and stopping behavior, and observing vehicle size and weight restrictions. After all, many routine trips and the delivery of day-to-day products and services depend on gravel roads. Without a doubt, gravel roads are a critical part of our transportation infrastructure and an investment worth protecting.
So next, If the gravel surface road is to be maintained for several years without bituminous or asphalt surface treatment or other impervious surfacing, AASHTO standard specifications requires maximum liquid limit of 35 and a plastic index of 4 to 9 and a maximum 8% passing the number 200 sieve. So, if ang gravel surface road ko i-maintain siya for several years nga hindi magamit sang bituminous or asphalt na surface treatment, gina-require sang AASHTO or na-specify na sang AASHTO standard, gina-require nga ang maximum liquid limit is 35, ang plastic index is 4 to 9, kag maximum 8% nga mapass, passing the number 200 sieve. So, mayroon na sa tapad niya, Table 7.1, grading requirements for soil aggregate materials. So, dahil nyo na makita ang grading requirements for soil aggregates. So, mabasa nyo lang na siya. Ang sieve design. So, naka millimeters inch, then percentage by weight, passing square mesh sieve. So, meron ka ta grading A, grading B, grading C, grading D, grading E, grading F. So, makita nyo lang nanda siya. Sa table 7 to 1.
The next topic is 7-3, Treated Base Course. To stabilize the base course, it is sometimes treated with either asphalt, lime, Portland cement, or other materials as binders mixed with the aggregate base course. Treated base course is adopted if in the study or analysis of the highway agency, a better road can be produced at a minimal overall cost, or when a politician ordered the highway office to construct the road with or without study because it was a commitment during the campaign period. Asphalt or bituminous treatment is employed to waterproof and bind the granular aggregate to the sand and clay. Thus, the primary function of the asphalt in a treated aggregate is waterproofing. Asphalt-treated base allows a thinner overall depth of the pavement. Different types of asphalt are used to bind the natural materials like untreated granular base and granular aggregate with sands and even clay. So to build strong roads, we mix special helpers like asphalt, lime, or cement with tiny rocks, sand, and clay. This creates a sturdy base that keeps the road from cracking. Asphalt acts like glue, sticking everything together and keeping water out. This helps make roads last longer and cost less to build. So next, the type of asphalt binders for base course depends on several factors. First, the mixing procedure is either by plant or field mixing. Second, if mixing is processed in the plant, the aggregate is heated to specified temperature and mixed with either asphalt cement, cutback asphalt, or emulsion asphalt. Third, the quality of asphalt is classified as either for stabilizing or for waterproofing purposes only. Fourth, if the purpose is for stability, mixtures are measured in the laboratory by the Marshall or HVEM stabilometer procedures. The weight of asphalt in percentage would probably in the range of 5% to 7%. Fifth, if the purpose is for waterproofing only, 2% to 3% of the asphalt binder is added. Lastly, if emulsion asphalt is used, enough water is included in the mixture to allow compaction at near optimum moisture content. So when choosing asphalt for road bases, engineers consider several factors. They decide first how to mix it, either at a plant or on site. Second, the asphalt quality for stabilizing or waterproofing. And the right amount. It's 2 to 7%. So there are different types of asphalt that are used. Asphalt cement for stability, cutback asphalt for flexibility, and emulsion asphalt for easier mixing. So these are HVEM stabilometer and Marshall stability test machine. Next, sand and asphalt base course. The sand and asphalt base course is composed of either loose beach sand, dune peat, or river sand cemented with asphalt materials. In the early road construction, sand and clay mixture is not only used as road surfaces but also for base courses. But lately, The cutback asphalt, emulsified asphalt, or tars have been introduced as substitute for the clay binders to produce quality base courses for roads and highways. Sand for mixing asphalt should be clean and strong, because the surface properties and grain shape must have the quality to resist displacement under load. If in the event that quality of available sand is not satisfactory, it may be blended with sharp angular particles like crushed aggregate, stone or screened slag, stone dust, loess, cement, or other non-cohesive minerals to produce a stable mixture. The test could be by the Hubbard-Field, Marshall, and HVEM stabilometer procedures. So, a sand and asphalt base course is a strong foundation for roads. It's made from clean, strong sand like beach, dune, or river, and asphalt like cutback, emulsified, or tar. So, the requirements for this is that first, sand must resist displacement under heavy loads. Second, sand quality can be improved by mixing with stronger materials like crushed stones, slag, or cement. So for testing, we have Hubbard-Field test, Marshall test, and HVEM stabilometer test. So next, asphalt binders with a grade of asphalt cement for hot plant mixing should be A, medium viscosity, rapid or medium curing asphalts, B, slow setting emulsified asphalt, or C, tars of grade road tar 6 to road tar 10. The content of asphalt binder is in percent by weight ranging from 4% to 10%. Compaction is done using either pneumatic tired or smooth-wheeled roller. In case the surface is tight and non-friable, sealing can be disregarded. So in application details, asphalt content 4 to 10% of total weight, compaction tools, pneumatic rollers or smooth-wheeled rollers, and sealing optional only needed if surface isn't smooth or tight. Next, fine-grained asphalt base. An asphalt stabilized base and subgrade constructed with fine-grained has a controlled plastic index of 6 to 10 respectively. Aggregates with plasticity index up to 30 are processed with lime. Those with up to 50% passing the number 200 sieve and plastic index up to 18 can be stabilized even without pre-treatment. So fine-grained asphalt base is a strong road foundation made from fine-grained soil and asphalt. So the requirements for this is that soil's plastic index or stickiness should be 6 to 10. Soil with higher stickiness, up to 30, it is mixed with lime. Soil with high sand content, up to 50%, can be stabilized without pre-treatment. So next, soil and base course stabilized with cement. The use of Portland cement in stabilizing soils and aggregates was initially practiced after World War I in 1914. First, cement stabilization by mixing natural materials and Portland cement compacted at optimum moisture content and cured to hydrate the cement is considerably strong and stable base. It is less susceptible to deformation caused by moisture and temperature changes. Second, comparatively, this is less rigid than the Portland cement concrete because its modulus of elasticity ranges from 100,000 for clay soils with little cement up to 1 million for the strong mixture. Its compressive strength ranges from 300 psi to 600 psi with flexural strength of about 20% of the compressive value. Third, Portland cement concrete modulus of elasticity ranges from 3 million to 6 million with compressive strength of about 3,000 to 5,000 psi. So after World War I, builders started mixing Portland cement with soil and aggregates to create strong road bases. This cement stabilization, the benefits is that it resists moisture and temperature changes, and it provides stability and durability. Its comparison to concrete is that it is less rigid than concrete. The flexural strength is 20% of compressive strength. The compressive strength is 300 to 600 psi. Next, the stabilized cement mixture is called soil cement, produced by using abundant native local materials subdivided into 3 types. First, sandy and gravelly soils containing less than 25% silt and clay. Second, sand with lesser amount of fines like beach sand, glacial, and windblown sand. And lastly, silty and clayey soils. Next, Materials having plasticity index greater than 30 is rarely used, unless lime is added. Materials with high pH or sulfate content are not advisable for use. The cement content for stabilized mixture ranges from 5% to 14% by volume of 3% to 16% by weight of dry aggregates. Sandy and gravelly soils required less amount of cement, unlike the silty and clayey soils that needs higher percentage of cement. The dry densities of cement stabilized mixture compacted by AASHTO standard methods ranges from 135 pounds per cubic foot for a well-graded gravel down to 85 pounds per cubic foot for silty or clayey soils. The recommended field density is about 95%. The quality of aggregate cement mixture is measured by its ability to resist abrasion and disintegration. Other methods of testing for stabilized cement content is the unconfined and triaxial compression and flexure tests. So the next topic is 7-4, grading and maintenance of untreated surface. The cross slope of untreated surface gravel road must be sufficient enough to drain water to prevent potholes and softening of the roadway. Thus, if the road materials are sufficiently stable and watertight, 1 inch per slope is considered satisfactory, although 3/8 to 1/2 inches per foot slope is preferred. If the road is steep grade, substantial cross slope is needed to direct the water into the roadside. So gravel roads need a slight slope to drain water. So why drainage matters? Because it prevents potholes and it stops the road from getting soft. So untreated surface road is seldom constructed in less than 20 centimeters loose depth. When compacted, will be compressed to about 15 centimeters thick. Road development sometimes adopted the stage construction methods, which means step-by-step improvement of the roadway, depending upon the availability of funds and demand of increased traffic. The sequence of improvement could be as follows. First, it might be an earth road surface. Second, untreated gravel road. Third, application of asphalt over the gravel. Fourth, the use of stone-type pavement with gravel as part of the base course. Maintenance of gravel road surface is a routine activity, especially in maintaining the smoothness of the surface under the following procedures. First, by cutting off a thin layer of the road surface using road grader, distributing the scraped layer uniformly over the roadway surface. The cut is deep enough to remove the corrugations of the road surface. Second, the blading sequence is once or twice a year or sometimes monthly, depending upon the finances, traffic, and equipment availability. After blading, the road is compacted by road roller to maintain the cross-section slope and the crown of the roadway. Third, the most effective routine maintenance is done immediately after rainfall, where the surface is soft for the blade to drag. Fourth, losses of materials caused by grading and traffic wear generally ranges from 1/2 to 1 inch of the thickness per year, although it varies due to traffic volume, rainfall, wind intensity, frequency, and maintenance practice or habit. Lastly, compaction is effectively done by using pneumatic, tired, or steel-wheeled rollers, where surface is tight and non-variable. Sealing may be omitted.
So next, we'll discuss about the DPWH standard specifications and aggregate sub-base scores. So, the Department of Public Works and Highways classified the aggregate sub-base scores as item 200, which consists of furnishing, placing, and compacting aggregate sub-base scores on a prepared subgrade. So, we have first the item 200 material requirements, that aggregates for subbase shall consist of hard durable particles of fragments or crushed stone, crushed slag or crushed or natural gravel and filler or natural crushed sand or other firmly divided mineral matter. The composite material should be free of vegetable matter and lumps or balls of clay that could be compacted readily to form a stable base. So, dara, based sa paragraph ta, ang item 200 material requirements kuno, ang aggregates kuno nga gamiton para sa subbase, dapat consisted siya kuno sang hard kag durable nga ng mga crushed stone, gravel, kag sand. Dapat free man siya kuno sa organic matter and clay para maka-form ta sang firm kag stable nga base. So, on the right side, makita tang table 7.2, you have the grading requirements for item 200. So, makita tada ang SIF designation standard alternate US standard. So, mga 50, 25, 10, 0.75 naka-millimeters ni sila, and then aring mga 2, 1, 3, 8 naka-inches. And then sa piyakis ang mass percent passing. So, next is the condition. Okay, conditions. Number 1, the fraction passing is 0.75 millimeters. 200 sieve should not be greater than 0.66. 2/3 of the fraction passing is 0.425 millimeter. Number 40 sieve. Number 2, the fraction passing is 0.425 millimeters. Number 40 sieve should have a liquid limit not greater than 35 and plastic index not more than 12 as determined by AASHTO T89 and T90 respectively. Number 3, the coarse portion retained in a 3 millimeters number 10 sieve shall have a mass percent of wear not to exceed 50 by the Los Angeles abrasion tests as determined by AASHTO T193. A CBR value should be obtained at a maximum dry density as determined by AASHTO T180 method D. So, next is ang item 201 material requirements. So, number 1, that the fraction passing is 0.075 millimeters. Number 200 sieve shall have a mass percent of wear not to exceed 50. The fraction passing is 0.425 millimeters. Number 40 sieve shall have a liquid limit not greater than 25 and plastic index not greater than 6. Number 3, the coarse portion retained on a 2 millimeters. Number 40 sieve shall have a mass percent of wear not to exceed 50. Number 4, the materials passing a 20 millimeters or 3/4 inches sieve shall have a soaked CBR value of not less than 80%. So, makita man natin sa right side ng table 70, ang grading requirements for item 201. So, ano na siya? Sieve designation, kagang mass percent passing. So, next is the item 202 material requirements. Number 1, The portion passing the 0.075 millimeters, number 200 sieve, shall not be greater than 0.66, or 2/3 of the portion passing the 0.425 millimeters, number 40 sieve. The portion passing the 0.425 millimeters, number 40 sieve, shall have a liquid limit more than 25 and plastic index not more than 6. Number 3. The coarse aggregate retained on 2 millimeters, or number 10 sieve, shall have a mass percent of wear not more than 45 by LA abrasion tests, and not less than 50 mass percent, shall have at least one fractured face. Number 4. The material passing a 20 millimeters or 3/4 inches sieve shall have a minimum soaked CBR value of 80%. So, nakita natin sa right side ng table 7.4, or gin-zoom ko siya. Ang item 201, crushed aggregate-based courses. You have the designation man Japan and ang mass percent passing. We have a grading A ka grading B. Next is the item 203, lime stabilized road mix base course. So, this item consists of foundation for a surface course composed of soil aggregate, lime and water proportion mixed on site and constructed on a prepared subgrade or subbase. So, ang item 203 ko no, is about siya sa lime stabilized road mix base course. So, ini nga item consists ako no sang soil aggregate, lime, kag water proportion nga gin-mix sa pag-prepare sa subgrade kag subbase. So, bale, ginaadan siya sang lime mixture. So, may material requirements tada. Number 1, soil aggregates refers to the combination of gravel, sand, silt, and clay or other approved combination of materials free of vegetable or other objectionable matter that might be encountered in the construction site or obtained from other approved sources. So, ang soil aggregate ko no, refers ako na sa combinations ng gravel, sand, silt, kag clay, or other mga approved combinations ng material nga wala siya sang mga organic matter, wala siya sang vegetable, kag iban pagid nga objectionable matter nga ma-encounter ta sa construction site. So, number 2, the intent of the specification is to utilize soil existing on the roadbed if the quality is satisfactory according to the specifications and minimizing cost. So, need din natin i-specify para mabalanta kung ang soil nga exist sa roadbed, kung ang quality niya ba ay satisfactory na based sa specifications. And number 3, on the contrary, if the material quality is poor or deficient, aggregate must be obtained wholly or partially from an approved outside sources. So, if, di ba sa number 2, muna ginahibalo mo siya if satisfactory na ba ang soil nga gi-exist sa roadbed. So, sa number 3, if ang material ko no, ang quality sa material is poor, dapat ko nung aggregate, dapat need siya i-obtain wholly or partially sa na-approve niya outside ng sources. So, ang sitapat niya nga table is ang table 7.5 for the grading requirements for item 203. So, ang Japan, sieve designation kag ng mass percent passing. So, next are the conditions. So, number 1, that the plastic index of item 203 should not be less than 4 or more than 10. The aggregate mass percent of wear should not exceed 50. Number 2, hydrated lime must conform to the requirements of item 701 construction lime. The amount of lime added to soil aggregate should be from 2 to 12 mass percent of the dry soil. So, sa number 1 ko no, munang plastic index ang item 203 dapat hindi sa magdubo sa 4 kag hindi man siya maglapaw sa 10. Tapos dapat ang aggregate mass percent sang wear is hindi siya maglapaw 50. So, sa number 2 naman, na state nga dapat ang hydrated lime dapat na makapasar siya sa requirements ang item 701 construction lime. So, ang amount ng lime na i-add sa soil aggregate, dapat ko no is from 2 to 12 mass percent sang dry soil. And number 3, lime should not be applied during windy, rainy, or with impending bad weather. So, ito magamit sang lime, hindi siya natin dapat i-apply if kalain sang trimpo, if gaulan-ulan, if gahangin, or may impending bad weather. Dapat hindi ta magamit namin sa sinang adlaw. Like, mga itataad ay itsimpuhon ta nga na-mix clar ta lime sa soil kung nami ang tsimpo. Like, gisani be, ang ulan ta na makaano. Pero pag windy, rainy, or may impending bad weather, hindi ta dapat mag-apply lime. So, number 4. The equipment to be used includes scarifier, pulverizer, mixer, spreader, hauler, water truck, compactor, and finishing machine, including slurry line distributor equipment. Number 5. Distributor equipment should include pressure gauge, volume measuring devices or a calibrated tank. It should be equipped with power until for the pump and full circulation spray bars, adjustable laterally and vertically, and also agitator to prevent setting of solid lime. So, magamit kita, di ba ambot ang lime sa soil, di ba lapad natin bukbot nga, dapat magamit kita equipment para mamix target natin sa insakto ang lime sa soil. So, amo na, included ng equipment nga arang pressure gauge, volume measuring devices, or ang calibrated tank. Okay, next is the preparation of the soil aggregate. So, case 1 for new soil aggregate. Number 1, the existing road bed is scarified lightly and bladed to a uniform grade according to the plan, then rolled, watered, and rolled. Number 2, all depressions appearing the surface are filled and the weak portions of the road bed is strengthened with new soil aggregate. Number 3, allow 1 day for measuring, sampling, and testing of the sample for approval of the quality and gradation before spreading the windrow for application of the hydrated lime. So number 4, if soil aggregate moisture exceeds 2 mass percent of the dry aggregates, apply aerasions by harrowing the soil aggregate until the moisture content is reduced to 2 or less. Okay, ang case 2 naman is ang salvage ko ng soil aggregate. At ang case 1 is para sa mga bagong mga soil aggregates. So next is ang case 2. So number 1, when materials in the site are to be used for mixing, the surface should be scarified lightly and bladed to form a grade conforming to the cross-section of the plant. Number 2, the reshaped surface is scarified again to depth required, leaving a foundation of undisturbed material parallel with the profile and cross-section. Number 3, the loosened materials are bladed into windrowed at the stride of the roadway. The undisturbed materials are then rolled, watered, and rolled. So next is ang application of lime. So number 1, so may mga procedures kita de. So we have 7 procedures. Sa pag-apply sang lime, dapat may follow siya nga correct procedure nga arang na-enumerate natin sa dalom. So may 7 ka bilog. Number 1, the hydrated lime is uniformly spreaded at specified percent using either the dry slurry or wet methods. So, ang hydrated lime ko is, siya, uniformly, nga na-spread kid, like, dapat, hindi siya kambang, like, dapat balance kid. Like, kung natin kadamuon sa left side bed, dapat, amo man ang kadamuon sa right side. Amo like, parehas ang kadamuon sa bilog kid. Para ma-spread gid siya, spread siya at specified percent, pwede ka kagamit dry or wet method sa pag-apply sa lime. So number 2, the lime is distributed in successive applications at the amount in intervals as prescribed. So number 3, the mixing equipment follows immediately by the distributor after each application to partially mix the lime and the soil aggregate. So, dapat kung magbutang ka bala na isang lime, dapat kasunod lang mixing equipment sa imo. Like, behind sang distributor. If nabutang na gid bala ang lime sa soil aggregate siya. So number 4, it is applied only to specific areas as can be mixed into the soil aggregate during the day of application. Number 5, the application is either by spotting bags of lime in equal predetermined transverse and longitudinal intervals or by applying in bulk tank from equipped self-loading trucks. So number 6, if lime slurry or wet is employed, the typical slurry ratio is 1,000 kilograms lime to 2 cubic meters water. The actual mixing proportion depends upon the percent of lime specified, the type of soil, and its moisture condition. So, if ang gamitin tayo ng method, so may diba, may dry siya kag slurry or wet method. So, if ang gamitin ko na natin is ang slurry or wet method, so ang typical nga slurry nga ratio is 1,000 kilograms ang lime kag 2 cubic meters ang water. So next, so the last one, to prevent runoff and consequent non-uniformity of line distribution, the slurries mix immediately after each spreading pass. So,
welcome to Mesquite, Texas. Out here, we are on site with LGE Design Build today, flying their job with some drones, and caught a little bit of the lime treatment process that they're dealing with right now. Here in North Texas, we have absolutely terrible soil as far as the top layer goes. We've got some shale underneath, some rock under that, but overall, the soil out here in Dallas and the DFW in the North Texas region is really bad. The reason why it's so bad is because as rain comes in, and as we get these summer days where it's really dry, what tends to happen is the rain will swell the soil and make it huge like a sponge, and then once it dries out, it'll shrink back, kind of like that crack effect if you've ever seen like a desert picture and it's cracked. Same thing. The water will just be gone immediately, and it will shrink back down to its old size. And then it will do that over and over and over again until it breaks your foundation to bits. So there are really three ways to kind of mitigate that here in the North Texas area. One is to import actual quality soil as your pad. The second is to moisture condition your pad, so taking all your soil and mixing water into it and then compacting it to get your maximum PVR. Your PVR is going to be your potential vertical rise. That's normally within the range of 2 to 15 inches in this area, which is a huge change in elevation when you hear water to soil ratios. Once they mix that soil in there, or that water in with the soil, they will then compact it on lifts until they get their maximum PVR and densities for that. The third option is also to put lime treatment out there. A lot of times you see lime treatment done on fire lanes or paving, but a lot of times it's also used on the top of the pad to help give it that firm foundation from the first 2 to 3 feet of the pad, and then below that, maybe 12, 15 feet of moisture conditioning. So I think that's what they're doing out here. They've got a moisture conditioning process with some of their Volvo excavators going on right now on a different pad, and then they're topping it off with another layer of lime on top. So as you can see, they've got tankers out here filled with that hydrated lime, and that lime is being shipped from a plant far away. They opted to go ahead and put a mobile plant out here on their site. That way they can have easy access to their pads at any time. So Loist, with U.S. Lime Company, is shipping in large quantities these tankers with the lime to fill up their on-site tanks so that they can take it with their trucks that they have on site and dump it on the pad. Once they've got it to the pad, what they've done is they've ripped up the soil on top of the pad with the rake of a dozer. That gives it easy access for all that hydrated lime to kind of seep into the soil and make it easy to mix. Once they've done that, and they lay down that lime, that hydrated lime out of the truck, then the pulverizer comes in right behind it and mixes that up. Once it's mixed up, they will typically flatten it out, kind of harden it down, and then let it cook for about 7 days. It's different in different, civil engineers will do 5-day cook time, 3-day cook time, 7-day cook time, something like that. They will let it sit there and cook over time to really help get that lime into the soil, and then they will come back with the pulverizer later and remix it. Once they remix it, they're able to go ahead and compact it and then be able to blue top it with those or make it a finished pad. So it's a really cool process out here. Hopefully you guys got to see a little bit of it, and if you guys want to ask any questions, throw them down in the comments. Hopefully you guys learned a little bit about the lime process and the soils out here in North Texas.
Next, mixing. So number 1, may mga mixing procedure man siya. So enumerated siya. So may 4 siya ka-procedure ang mixing. So number 1, after the last lime application and partial mixing, the entire mass of mixture is withdrawn on the road surface and then mixed by blading the mixture from side to side of the road or by manipulation, producing equivalent results until the whole mass has uniform color. The mixture should be free from thin spots or balls of unmixed particles. Number 2, should the mixture show an excess of deficiency or uneven distribution of lime, the condition must be corrected by adding soil aggregate or lime then mix. So, di ba na-mix mo na siya? So, ma-mix mo siya pag isang blading. Pag-blade. So, wala do, may treatment na siya sa pag-blading mo. Para mo na ma-mix mo gid siya. And then, from side to side, equal, gid ba lang nga pag-mix, hindi ang mula na nga side ang i-mix mo. Hindi, like, dapat bilog gid. So, and then, pag na-mix mo na siya, na-mix mo na gid siya sa insakto, mabalat mo lang na siya based sa, if ang whole mass, uniform na ang color niya. So, if ang mixture ko na nag-show siya sang excess nga deficiency or uneven nga pag-distribute sang lime, ang condition ko na dapat i-correct gid paagi sang pagdugang sang soil aggregates or pagdugang ta sang lime, then i-mix na siya. So next, so number 3, if the mixture contains excessive amount of water or volatile matter, as may be encountered in slurry operation, it should be bladed, aerated, or manipulated until the moisture and volatile content becomes satisfactory. So, di ba mix ka to? Like, if pag-mix mo kung nasobrahan mo ba ng water or volatile matter, kaya di ba sa slurry or wet method, kinalamig sa water. So, dapat, if magsobra ko nung mat sa water, dapat should be bladed ko aerated or manipulated until ang moisture kag volatile content maging satisfactory na siya. So number 4, last, whether mixing is completed or not, all loosened materials are bladed into a windflow at the end of each day, work and retained as such until operations resumed. So next is ang spreading, compacting, and finishing. So the methods of spreading and compacting and finishing are enumerated as follows. So may method man siya. Ang pag-spread, pag-compact, ang finishing na. So number 1, the materials are spreaded by self-propelled pneumatic tired blade grader or mechanical spreader of approved type cutting into the blade. Underlying course should be avoided. So after the spreading, the surface is leveled to the road center line, then to the other edges of the road overlapping the shoulder. Number 3, each pass should terminate at least 90 minutes in advance or to railroad and the other preceding pass. So next, during the time of compaction, the surface is drugged or bladed as necessary to peel and remove incipient. So number 5, rolling must be continued until after the surface is in uniform texture, satisfactorily compacted. Number 6, rolling should be stopped whether there is an excuse pulverizing of the aggregate or displacement of the mixture. So next is ang protection, curing, and maintenance. So, basahon ko lang ganyan siya. So, after stabilizing the base course by lime, it is protected against rapid drying for a period of at least 5 days by either of the following curing methods. So number 1, a thorough and continuous moist condition should be maintained by sprinkling water. Number 2, the surface must be covered with 50 millimeters layer of earth or sand and maintained in moist condition. Number 3, the surface is applied with asphalt membrane of the type and quantity approved by the highway agency. So we have the item part 4, Portland cement stabilized road mix base course. So this item consists of a foundation for surface course composed of soil aggregates, Portland cement, and water. Proper proportions of road mix placed on a prepared subgrade or subbase. So, dali, sa item part 4, consists na siya sang soil aggregate, Portland cement, kag water. So, proportioning mixture. Number 1, the amount of cement added to the aggregate shall be 6 to 10 mass percent of the dry aggregate. Number 2, construction requirement and procedures is the same as that of item 203, wherein the word lime is deleted and replaced with Portland cement. So, meron makita item 205 and then item 206. So, item 205, asphalt stabilized road mix base course. Materials, asphalt materials should be anionic or cationic. Emulsion asphalt of the slow setting type. So, we have mixture proportion. The amount of asphalt material to be added to the aggregate should be from 4 to 7 mass percent of the dry aggregate. So, item 206, Portland cement treated plant mix base course. We have a travel plant mixing method. So, travel plant mixing method, the salvage on the aggregates is pulverized until at least 80 mass percent of all the materials other than stone or gravel passes a 4.75 millimeters number 4 sieve. Any material retained on a 50 millimeters or 2 inches sieve and other unstable. Unsuitable materials are removed. So we have procedures 1. So number 1, aggregates to be treated is placed in uniform windrows spreaded to uniform thickness to the required depth. 2, Portland cement of proper quantity is applied uniformly in a trench on top of the windows or spreaded uniformly over the aggregates. Number 3, mixing is done by machine or thorough uniform blended mixture. Number 4, when this method is used, a maximum time of 2 hours is allowed for wet mixing, letdown, and finishing. So next, central plant mixing method. The plant is equipped with feeding and metering devices that will introduce the cement aggregate and water into the mixer in quantities din ako to specified. So, basan ko na lang ito ulit. Central plant mixing method. The plant is equipped with feeding and metering devices that will introduce the cement aggregate and water into the mixer in quantity specified. Mixing continue until after uniform mixture is attained. So C, spreading, compacting, and finishing. Not more than 60 minutes should elapse from the start of mixing to compaction of the laid mixture. So after spreading, the mixture is compacted and stabilized, and finished in accordance with the procedures as enumerated for lime stabilized road mix base course item 2 to 3. Our next topic, which is clearing and grubbing. Clearing and grubbing is categorized under Item 100 of the DPWH Standard Specifications. It consists of clearing, grubbing, removing, and disposing of all vegetable matter and debris except those objects that are designated to remain in place or are to be removed in consonance with other provisions of the specifications. It also includes preservation from injury or defacement of all objects designated to remain. So, ang clearing and grubbing ko means ang pag-remove isang plants, sa mga debris, sa obstacles, pag-dispose ng waste, at pag-safeguard sa mga remaining structures. So, specifications for clearing and grubbing provides that. I-zoom ko dahil kitaan siya. So, number 1, all surface objects and all trees, stumps, roots, and other protruding obstructions that designated to remain should be cleared and or grubbed, including the mowing required as follows. So, tanan ko ng mga surface objects, like para bisang mga trees, sang stumps. So, when you say stumps, ang siyang remaining na base or lower part sang tree. Lower part sang tree trunk after the tree has been down or fallen. Like, ang nabiling niya na lang nabala if natapas na bi ang kahoy. So, ang remaining niya nga base or ang lower part na sa tree trunk, naman siya ginatawag na stump. So, ang na stumps, roots, kag other nga mga gubulto ko nga mga obstructions, need gid na siya i-clear. Unless na lang kung need siya nga amo na ba lang nga i-remain lang ng amo na siya nga amo na lang nga bagay kag hindi siya need i-clear. So unless na lang kung amo na siya. So okay, A, we have the removal of undisturbed stumps and roots and non-perishable solid objects with a minimum depth of 90 centimeters below subgrade or slope of embankments will not be required. So, no need na kuno nga i-remove ang stumps or objects nga 90 centimeter below ground level. So, B naman, B, outside the grading limits of cut and embankment areas, stumps and non-perishable solid objects should be cut off not more than 15 centimeter above the ground line or below low water level. So, outside ko sa mga graded areas, cut stumps 15 centimeter above ground or below water level. So, iutudan na to ko, no? Ang stumps 15 centimeter above ground or below water level. Muna i-cut ko na naton. If outside na siya sa grading limits, i-cut ta. Grading limits ang cut embankment areas, ang stumps, kag non-perishable solid objects, dapat i-cut off siya. Hindi siya maglapaw sa 15 cm above the ground line or below sang low water level. Dapat di siya maglapaw 15. Okay. C, in areas to be rounded at the top of cut slope, stumps should be cut off flush with or below the surface of the final slope line. So, ang pagkatas ng stumps, cut stumps flush or below surface on slope areas. So, i-cut ang mga stumps ko na should be cut off flush with or below sa surface ang final slope line. So, next, grubbing of pits, channel changes, and ditches will be required only to the depth necessary by the proposed excavation with such areas. So, ang kadalooman ko na sa pag-grubbing, dapat gamatch siya sa na-propose ng excavation depth. Like, kung ano kadalo ng excavation, dapat amo man na ang depth sa pag-grubbing. So, last is the burning should be under constant care of competent watchman, that the surrounding vegetation, adjacent property, or anything designated to remain in the right of way will not be jeopardized. So, dapat ma-burn responsibly ka man. Para protektahan, dapat need mo sang watchman para maprotektahan ang surrounding na vegetation or property. Like, dapat under constant care gid siya sang competent nga watchman ang pagsunog. Kay para hindi ka makaapekto sa surrounding na vegetation or property. So, next is the methods of measurement. So, we have number 1, area basis, 2, lump sum basis, 3, individual unit basis, or selective clearing. So, makatuto na lang sa number 1, which is the area basis. So, area basis, by hectare and fractions thereof acceptably cleared and grubbed. So, sa area basis, ang pag-measure ko, isang cleared area is hektarya. Like, bayaran mo kuno kada hektarya nga na-cleared. So, number 2 naman is ang lump sum basis. No measurement of area will be made for this item. like sa lump sum basis ko, no, like single fixed payment gina siya, like kung ano na inyo na istoryahan na payment, like amo na ginang fixed na payment, way na siya add-ons, way na dugang, kag wala na required nga area measurement. So last is individual unit basis or selective clearing. The diameter of trees will be measured at a height of 1.4 meters above the ground. Trees less than 15 centimeter diameter will not be measured for payment. So sa individual unit basis naman or selective clearing, so gina-measure naman ang diameter ng trees will be measured sa height at a height sang 1.4 meters above sa ground. Kag ang pagbayad diri sa individual unit basis ay ano siya, pay per tree. Kag only sa trees lang greater than or equal to 15 centimeter ang diameter. So, if ang trees ano siya less than sa 15 centimeter ang diameter, wala ka bayaran. Okay. So the unit basis will be designated and measured in accordance with the following schedule of sizes. So diameter at height 1.4 meters, na pay item designated. Over 15 to 90 centimeters, small. Over 90 centimeter, large. So, meron ka tade videos ang clearing and grubbing.
So the next topic is 7-7, excavation. Excavation is the process of loosening and removing earth or rock from its original position in a cut and transporting it to fill or to waste deposit. Roadway excavation is classified into unclassified excavation, rock excavation, common excavation, muck excavation, and burrow excavation. So unclassified excavation is the excavation and disposal of all materials, regardless of its nature, are not classified and included in the bill of quantities under other pay items. So, in short, removing mixed materials, any type. So, in rock excavation consists of igneous, sedimentary, and metamorphic rocks that cannot be excavated without blasting, or the use of rippers and all boulders or other detached stones, each having a volume of 1 cubic meter. So, in short, blasting or ripping hard rocks and boulders. So, in common excavations are those that are not included in the bill of quotations under rock excavation or other pay items. So, in short, regular digging, not rock or specialized. So, in muck excavation consists of the removal and disposal of deposits of saturated or unsaturated mixtures of soils and organic matter not suitable for foundation materials regardless of moisture contents. In short, removing soggy, unstable soil and organic matter. Lastly, the burrow excavation. Burrow excavation is the excavation and utilization of approved materials for the construction of embankment or for other portions of the work obtained from approved sources in accordance with the following requirements. First, burrow case 1. Materials obtained from sources designated on the plans or in the special provisions. Second, burrow case 2. Materials obtained from sources provided by the contractor. So, the burrow case 1 is the designer approved sources, while the burrow case 2 is the contractor provided sources.
Excavation is a critical process in construction, used to prepare building sites by removing soil and rocks from the ground. Here are some key points to know about excavation in construction. Purpose of excavation. The primary purpose of excavation in construction is to create a foundation for a building or other structure. This involves removing soil, rocks, and other materials to create a level surface where the foundation can be built. Excavation may also be necessary for other purposes, such as installing utilities, building retaining walls, or creating drainage systems. Types of excavation. There are several types of excavation used in construction, including strip excavation, basement excavation, and trench excavation. Strip excavation involves removing soil from a large area to create a level building site. Basement excavation involves digging a hole in the ground to create a basement level for a building. Trench excavation involves digging a narrow, deep trench for the purpose of installing utilities or other features. Excavation equipment. Excavation work in construction is typically done using heavy machinery, such as backhoes, bulldozers, and excavators. These machines are designed to remove large amounts of soil and other materials quickly and efficiently. Smaller tools, such as shovels and handheld excavation tools, may also be used for more precise work or in areas where heavy machinery is not practical. Safety considerations. Excavation work in construction can be dangerous, especially when heavy machinery is involved. Proper safety measures, such as fencing off the excavation site, using proper protective gear, and following strict safety protocols, are critical to avoiding accidents and injuries. Regulations and permits. Excavation work in construction is subject to a range of regulations and permit requirements, including environmental regulations and local building codes. It is important to obtain the necessary permits and approvals before beginning excavation work, and to follow all regulations and guidelines throughout the excavation process. Overall, excavation is a critical part of construction and requires careful planning, skilled workers, and adherence to safety regulations to ensure that the excavation is carried out safely and effectively.
Construction requirements. First, when there is evidence of discrepancies between the actual elevations and that shown on the plans, a pre-construction survey with reference to the datum plane used in the approved plan is undertaken by the contractor or agency to serve as basis for the computation of the actual volume excavated. Second, all excavations should be finished to smooth and uniform surface. As much as possible, no materials shall be turned to waste. Materials outside the limits of slope should not be disturbed by the excavation operations. Excavations should be done only after the clearing and grubbing in the area. Third, topsoil encountered in excavation and on areas where embankment is to be placed should be removed to the depth as the engineer may determine and should be transported and deposited in storage pile designated areas separated from other excavated materials for later use. So construction excavation requirements. Before building, we should verify plan elevations with actual site measurements. So the excavation rules. First, finish surfaces smoothly and uniformly. Second, minimize waste. And third, avoid disturbing materials outside excavation limits. So the preparation for this is that first, clear and grub. Remove vegetation and debris before excavating. And second, set aside topsoil for later use, separating it from other excavated materials. The use of excavated materials. All suitable materials removed from the excavation area are used in the formation of first, embankment, raised areas, second, subgrade or base layer, third, shoulders or road sides, fourth, slope, fifth, bedding or foundation layers, and lastly, backfill for structures or filling gaps around structures. All unsuitable materials that could not be properly compacted in embankment must be disposed of without delay, for it might be included in the work when the engineer turns his back for a cup of coffee. Borrowed materials should not be placed until after the field accessibly roadway excavation has been placed in the field. So unsuitable materials is removed promptly and not used for construction. And the borrowed materials is used after completing accessible excavation and approved materials only. Pre-watering and pre-splitting. Excavation areas and borrow pits may be pre-watered before excavation. When pre-watering is adopted, the areas to be excavated shall be moistened to the full depth from the surface to the bottom of the excavation. The water must be controlled so that excavated materials will contain the acceptable moisture content to permit compaction to the desired density. So pre-watering has to be supplemented where necessary by truck watering unit to ensure that the embankment materials contains the proper moisture at the time of compaction. Pre-splitting is drilling and blasting procedure that may be employed to control overbreak and to give a uniform face to the back slope or rock cuts. Next, pre-splitting is performed by drilling holes at uniform intervals along the slope line, loading and stemming the holes with appropriate explosives and stemming materials, and detonating the holes simultaneously. This process creates a clean, stable rock face, minimizing damage beyond the desired boundary. If the pre-splitting is under contract, prior to drilling operations, The contractor shall furnish the engineer a plan outlining the position of all drill holes, depth of drilling type, and explosive to be used, loading pattern, and sequence of firing. The drilling and blasting plan is for record purposes only, and will not absolve the contractor of his responsibility for using proper drilling and blasting procedures. Controlled blasting must begin with a short test section of length to be approved by the engineer. The test section shall be pre-splitted, production drilled and blasted. Sufficient material sample to be taken for the engineer to determine if the contractor's method is satisfactory. The holes are charged with explosives of the size, kind, strength, and spacing suitable for the formation being pre-splitted, and with stemming material which passes a 3 inches standard sieve which has the qualities for proper confinement of the explosives. The finished pre-split slope should be reasonably uniform and free of loose rocks. Variance from the true plane of the excavated backslope should not exceed 30 centimeters. Localized irregularities or surface variations that do not constitute safety hazard or impairment to drainage courses or facilities will be permitted. The maximum offset of 60 centimeters will be permitted for construction working bench at the bottom of each lift for use in drilling the next lower pre-splitting pattern. The engineer may order discontinuance of the pre-splitting when the materials encountered are unsuitable for pre-splitting. So this is pre-watering. The example of pre-watering.
Is about the freehaul or overhaul, item 107. So, before we proceed, explain ko dali kung anong haul. So, ang haul refers sa transporting goods, materials, or equipment from one location to another, typically over land. So, ang other term ni sa haul is shipping or transport. But, naman ako na, research. So, okay. Freehaul distance is the specified distance wherein an excavated material will be hauled without additional cost. The freehaul distance is 600 meters unless otherwise specified in the contract. Okay, so ang freehaul distance, na siya, distance nga, ginahaul, nga wala bayad, wala siya additional cost. So, ang freehaul distance is 600 meters. Unless na lang kung may na-specify sa contract na nga distance, ikaw mo gina siya ang gamiton. Pero usually, ang common ligid nga ginagamit is 600 meters. So, next is the overhaul. So, is an authorized hauling in excess of the freehaul distance. For example, if the hauling distance of materials is 800 meters, considering that the freehaul is 600 meters, then the excess 200 meters is considered overhaul. Okay. So, bali, dito naman sa overhaul is may bayad naman siya. If maglapo siya, nilapo na siya sa 600 meters. So, kung sa freehaul, wala siya bayad, free siya, wala siya additional nga cost. Sa overhaul naman is may additional siya nga, balayran, kinaglapo ko na sa 600 meters. Like, for example, like dire ang imo ko no hauling distance is 800 meters. So considering ang freehaul ko na 600 meters, ang excess mo nga 200 meters considered din ng overhaul. Tapos need mo na siya bayaran. Okay, next. Next is the methods of measurement. The overhaul distance for material obtained and placed within the roadway limits will be measured along the center line of the roadway. No allowance will be made for transverse of lateral movement to or from the center line except materials moved to or from designated areas outside the roadway limits. If the contractor chooses to haul materials from other road, which is longer than the designated source, payment will be based on the overhaul distance measured along the route designated by the engineer. Payment will be made based on the number of cubic meters overhauled materials multiplied by overhauled distance in kilometers. So, ang overhaul distance ko no is measured along sa roadways center line. So, excluded na ako ng lateral movements unless na lang kung materials are moved to or from designated outside areas. So, ang payment ko na is calculated pag sa pag-multiply sa volume of overhauled materials kitang units in is cubic meters. I-multiply mo siya sa overhaul distance in kilometers. So, amo na makuha mo ang payment. Para mabalaan mo kung pila ang imo balayran sa tungod sa imo naglapaw na nga distance tungod sa overhaul. So, muna pag-measure sa pavement. Pag-calculate.
So the next topic is 7-9, construction of fields and embankment. A stable embankment is attained by spreading the materials into a thin layer, then compacted at a moisture content closer to optimum. This layered process of compaction produces uniformity and higher density of the material and moisture content. On the other hand, filling materials which are just dumped in thick layers, even if compacted, will have a varying density and moisture contents from one spot to another. This will result to differential settlement or swell between the adjacent areas of the embankment. Dumping thick layer causes uneven density, varied moisture content, and settlement or swelling differences. The AASHTO-ARBA Joint Committee on Compaction of Earthwork proposed the following amendment to the original AASHTO density requirements to wit: granular aggregates or those with only slight degree of plasticity should be compacted to 95% to 100%. Fine-grained aggregate possessing a low degree of plasticity is compacted to approximately 100% at a moisture content near laboratory optimum. Densities for aggregate possessing moderate to high plasticity should not be so high as to lead to subsequent swelling. Compacting procedures should not exceed the aggregate shear strength. Clay soil should not be overcompacted beyond above 90% to avoid post-construction swelling.
Welcome to the module on construction of embankment process. Do not forget to subscribe if not yet done. Share your valuable feedbacks at pgr7074yahoo.co.in. A road, railway line or canal is normally raised onto an embankment made of earth to avoid a change in level required by the terrain, the alternatives being either to have an unacceptable change in level or detour to follow a contour. Embankments are often constructed using materials obtained from cutting. Embankments should be constructed using suitable materials to provide adequate support to the formation and long-term stability. Embankment is defined as the height of construction required to match the subgrade bottom at any given location. The height of embankment is generally calculated as the difference in levels of finished road level and the original ground level, the subgrade and the crust thickness at any given location. The bed is made ready to receive the fresh material for new layer construction by sprinkling water and doing a plain pass. Care should be taken to collect the material from the approved borrow areas for better performance. If there is a change in the borrow area, then the same needs to be immediately intimated to the central lab for collection of sample and testing. Material suitable for earthwork has a Proctor value of 1.52 grams per cc for a height of 3 meters and 1.65 grams per cc for a height more than 3 meters in embankment construction. Soil having the liquid limit value 50%, plasticity index not more than 25, FSI limited to 50%, and maximum particle size 75 mm is suitable for the embankment work. The quantity of earth required is calculated based on the layer thickness and the width per meter run in length. Depending on the compaction factor, the loose thickness is considered for dumping of soil. The calculated quantity of earth required to fill is dumped using the dump trucks as shown in the video. Supervisors will guide the dumping of materials in the bed so that it will be easy for the grading and removal of vegetations, if any, in the soil. Constant watch on the number of trips dumped on the bed will ensure the thickness of the compacted soil to be maintained. Generally, we prefer to have a 250 mm layer compacted thickness to be maintained in embankment. The movement of vehicles in the forward and backward directions with jerk while lifting the dump bed will ensure the proper unloading of the material from the truck during the process of construction of embankment as shown in the video. The hydraulics were used in lifting the dump bed to the extent required so that the tailgate opens automatically and allows the discharge of the material on the bed. The natural moisture content available shall be tested using the rapid moisture meter while dumping the soil so that additional water, if necessary, can be sprinkled to achieve the OMC during the rolling. It is required to maintain the correct moisture level during compaction, as with the increase in the moisture the density increases and then decreases after achieving the OMC for a particular soil. The roots and vegetation shall be removed from the bed before rolling and finishing. Particles bigger than 75 mm shall be removed from the bed if they are not being crushed to smaller size during the process of rolling. The heaps shall be uniformly spread by the dozer to achieve the required thickness. The dozed material can be graded to maintain the level and the camber as per the design drawings. The water sprinkled using the sprayer fixed to water tanker as shown in the process. Water is uniformly spread to achieve the required moisture for optimum compaction. The moisture shall be always within the range of OMC +1 and -2%. Grading is done using the motor grader to spread the material uniformly, maintaining the line and levels as per the drawing. The angle, tilt or pitch and height of the grader blades can be adjusted to achieve the precision grading of a surface. In civil engineering, the grader's purpose is to finish the grade, to refine or set precisely the bed at the required level. A more recent innovation is the outfitting of graders with grade control technologies. Such as those manufactured by Topcon Positioning System, Trimble Navigation, Leica Geosystems or Microfilm for precise grade control and potentially stakeless construction. Manufacturers such as Caterpillar have also begun to interface these technologies into their machine out of the factory. For the best results, it is always advisable to compact the surface at the optimum moisture content, as maximum density can be achieved at this moisture level. As the moisture dries up, even the highest compactive effort will not result in meeting the requirements, thus failing the surface. Because FDD reduces with the reduction in the moisture during compaction, thus the ratio FDD by MDD results in achieving less compaction than required in the field. Even after compaction, the vegetations, if any, shall be removed from the bed manually for better quality. As the moisture dries up, even the highest compactive efforts will not result in meeting the requirements, thus failing the surface. Visually, no impression of the tires visible on the bed, then the bed shall be considered as well compacted. Localized patches of impressions indicates the possibility of the entrapped air in the region and shall be removed before proceeding further.
Basically, there are two procedures employed to assure specified embankment density. First, to specify the expected value to the minimum acceptable amount of relative compaction and to ascertain from the field density tests that the specified value is obtained. Second, to specify the manner and methods of constructing the embankment, particularly the layer thickness, moisture control, and the number of passes by a roller of specified type and weight. So field control is a matter of ascertaining and defining the specific procedures to be done. What is important is the manner and methods that will yield the expected result. So this is the table 7-6 recommended minimum requirements for compaction of embankments. The problems encountered in the control of embankment construction are: first, difficulties in maintaining uniform moisture content. This is due to variable wetness of the soil, problems in evenly distributing and mixing in water, and evaporation or rainfall during compaction. Second, some soil may not easily assimilate water unless wetting agent is employed. Sometimes soil type cannot be segregated during construction unless brought to laboratory. Third, materials are hauled from different sources and segregation of the same type is difficult in the actual work. Next, the construction requirements and equipment. Density test requirements, moisture control, compaction equipment like tamping roller, grid rollers, pneumatic tire roller, smooth tire roller, vibratory compactor, and hauling and spreading equipment. So tamping roller varies from light unit test weight 6,000 to 10,000 pounds for an 8 feet width. For giant fully loaded roller, 75,000 pounds for a 10 feet width. Grid rollers is effective in breaking down clods and soft rock. Pneumatic tire roller with rubber tires weighing 8 tons or more, 200 tons for airport. Smooth tired roller of 2 or 3 wheeled type used to compact bases and bituminous surface. Vibratory compactor is effective in compacting stones of macadam road. Hauling and spreading equipment. Hauling equipment in particular is used to move building or drilling supplies, soil, and other materials. Below is an overview of the types of hauling equipment commonly used in construction and more. Cranes, bulldozers, excavators, loaders, shovels, tractors, and trucks. Embankment on swampy areas. Conventional construction of roadways in swampy area is not advisable because record shows that muck and plate provide unstable support for fields, causing failure of highways and railroads. Construction of roadway through swampy area requires either of the following methods. First, removal and replacement of unsuitable materials. Second, displacement under the following methods: surcharging method or adding weight, vertical sand drains or improved drainage, fabric reinforcement or added stability, and weight reduction or lighter materials. Removal and replacement method is applicable where the unstable material is shallow or thin. unstable materials are removed to the level of the underlying materials before filling. So it removes shallow unstable material and then replace with stable material. So displacement method, imported materials are carefully placed along the advancing slope, allowed to flow under the dense muck to displace it. Sometimes a trench almost equal to the width of the embankment may be blasted out and backfilled at once with stable materials. The blast pushes part of the muck out of the trench and the other portion is liquefied for easy displacement. Where muck is deeper or thick, the underfill method of displacement is applied. The trench is blasted and a large volume of the fill material is dropped to settle into the peak. So it places material along slope and displaces muck. Next. So the relief method is also employed after the fill materials are dumped in place. Relief ditches are blasted along the side of the fill to displace the underlying muck. So in relief, blast ditches beside fills and displace underlying muck. So insert charging method is applied on low fill over shallow muck up to 30 or 40 centimeters depth. Where top of the muck is soft, displacement through careful filling is done. The fill is then built up in compacted layers to its elevation, allowing settlement to its final grade. Surcharge of uncompacted fill material is laid to add weight and accelerate the flow of water from the muck, speeding up consolidation. Care should be exercised not to exceed the shearing strength of the muck, otherwise displacement of the muck and settlement of the fill may take place. After a period of consolidation, the surcharge material is removed and replaced with base course and temporary pavement. So in surcharging, used for shallow muck, less than 30 to 40 centimeters, and add weight, accelerate consolidation. Next. The vertical sand drain method provides rapid consolidation of deep layer muck. Sand drains are vertical columns of sand that penetrate the muck almost to solid materials. Across this top is a horizontal blanket extending through the side slope of the fill. Under the pressure induced by fill and surcharge, subsurface water flows up the drain and out of the fill. Rapid consolidation of the muck follows. So sand columns penetrate muck. Water flows out, rapid consolidation. So in the fabric reinforcement method is covering the muck with permeable fabrics. So in weight reduction method is installing a block of styrofoam over the muck to reduce the weight of the fill.
Hi guys, hope you all are doing good. Welcome to my YouTube channel. Today in this video, I am gonna share with you some details for the construction of road where the water is all around the surface of the ground. As you can see, the water is hovering all around the place. That's why in order to solve this problem, you can see that we have placed the boulders. After placing the boulders, we have put sharp sand and then we are placing the laterite. Once we complete the filling of boulders and sharp sand, we shall do the sub base and base. As you can see here that we have started placing the laterite for the sub base. We are also pouring water all around so that it can gel well. You can see that payloader is being used to spread the laterite. After placing the laterite, we use this smooth roller as well as the sheepfoot roller. Make sure you do the compaction properly, since this place is very delicate. You have to make sure that you use sheep foot roller as well as this smooth roller, because these rollers help you to achieve a very good compaction. After doing the compaction, you can see that we are using the grader in order to do the grading of this laterite. After the completion of sub base, you can see that the base course was started. This is the top of our double cell box culvert. So it was around this place where we found a lot of water on the surface. This is the reason why we had to use boulders as well as sharp sand. So guys, I hope you found this video a very interesting one. Thank you so much for watching this video. Until my next video, goodbye.
Next, DPWH Specifications on Embankment. Item 104. Embankment shall be constructed of suitable materials defined as: first, suitable materials. Suitable materials are materials acceptable that could be compacted in accordance with the contract as specified. Selected barrow for topping. Soils graded particles that passes a 75 mm or 3 inches sieve, square openings, and not more than 15 mass percent will pass the 0.075 mm or number 200 sieve. The material shall have a plastic index not more than 6 and liquid limit not more than 30. Second, unstable materials. Unstable materials are materials other than suitable materials, such as materials containing detrimental quantities of organic substances like grass, roots, and sewage, highly organic soils like peat and muck, soils with liquid limit exceeding 80 and or plastic index exceeding 55, soils with natural water content exceeding 100%, soils with very low natural density of 800 kg per cubic meter or lower. Methods of construction. First, where embankment lower than 120 cm below the subgrade is to be made, all sods and vegetable matters are removed from the surface. The cleared surface should be totally broken up by plowing, scarifying, or steeping to a minimum depth of 15 cm. Sods not required for removal should be disked, harrowed, or scarified before the construction of embankment. Second, roadway embankment on earth materials are placed in horizontal layers not exceeding 20 cm loose volume, then compacted as specified before the next layer is placed. Third, when excavated materials contains more than 25 mass percent of rock larger than 15 cm in greatest diameter and cannot be placed in layers of the thickness prescribed without crushing, pulverizing, or further breaking down into pieces, such materials may be placed on the embankment in layers not exceeding in thickness the approximate average size of the larger rocks but not greater than 60 centimeters. Fourth, lifts of materials containing more than 25 mass percent of rock larger than 15 centimeters in greatest dimension should not be constructed above an elevation of 30 centimeters below the finished subgrade. The balance of embankment should be composed of suitable material placed in layers not exceeding 20 centimeters in loose thickness and compacted as specified for embankment. Fifth, hauling and leveling equipment should be routed and distributed over each layer of the fill to make use of compaction efforts affording and to minimize rotting and uneven compaction. Next, compaction. The Contractors shall carry out full-scale compaction trials on areas not less than 10 meters wide and 50 meters long. Compaction trials with the main types of fill materials to be used in the work should be completed before any work with the corresponding materials is allowed to start. Throughout the period of compaction, the contractor should adhere to the compaction procedures found during the compaction trials for each type of materials, compaction equipment employed, and each degree of compaction specified. Before construction, conduct trials 10 meters by 50 meters for each fill material, then test main fill materials. During construction, follow trial procedures, use approved equipment, and achieve specified compaction levels. Protection of roadbed during construction. During the construction of roadway, the roadbed should be well maintained and drained at all times. Slide ditches or gutters emptying from cuts to embankment or otherwise should be constructed to avoid damages to embankment by erosion. So the key steps: maintain roadbed cleanliness, ensure good drainage, build slide ditches or gutters, and prevent erosion. So next, rounding and warping slope. Rounding. Accept solid rocks, the top and bottom of all slopes, including the slopes of drainage ditches, are rounded as planned. A layer of earth overlapping rock is rounded above as was done in earth slope. Warping. Adjustment in slopes are made to avoid injury to standing trees or marring of weatherhead rock or to harmonize with existing landscape features, adjusting to the gradual slope. At the intersections of cuts and fills, slope are adjusted and warped to flow into each other or into the natural ground surface without noticeable break. So in rounding, smooth slope tops and bottoms. Apply to all slopes except solid rock and blend earth layers over rock. While warping, adjust slopes around trees or rock formations, harmonize with natural landscape, and blend cuts and fills seamlessly.
Okay, let's proceed to our next topic, which is the subgrade preparation. Subgrade preparation is categorized under item 105 of the TPWH standard specifications. The subgrade is prepared for the support of overlying structural layers extended to the full width of the roadway. So, sa subgrade preparation, na-involve ang pag-prepare sang road foundation, pagis ang pag-level sang road, pag-compact sang soil, kag pag-ensure sang stability. So, ang purpose ni sa subgrade preparation is para masuportahan ang upper structural layers ng asphalt or concrete. And para ma-prevent man ang settling or shifting. Kag make-sure man ang road durability and safety. So, material requirements. Number 1, except when the subgrade is in rock cut, all materials below the subgrade is leveled to a depth of 15 centimeters or more as specified to meet the requirements of selected barrow toppings. So, i-level ko ng materials 15 centimeter or may na-specify na being a depth. So, depende. Pero common gid is 15 centimeter. So, below the subgrade surface except for rock formations. So, i-level mo ko ng materials sa na-specify nga depth. So, below the subgrade surface except sa mga rock formation. Number 2. Prior to start the subgrade preparation, all culverts, cross drains, conduits, and the like, including the backfill, ditches, drains, and drainage outlets are thoroughly compacted. Any work on the preparation of the subgrade should not be allowed to start unless approved by the supervising engineer. So, i-compacted ko ng mga existing structures like mga culverts, cross drains, conduits, backfill, ditches, drains, and drainage outlets. So, ihatag ko ang definition na sa kada isa na. As a review, di ba ang sum ni nga mga terms is na na-explain na sa other group. Pero as a review, as a recap, ihambak ulit ang definition nila. Okay, so first is ang culverts. So, i-compact ang culverts. Ang culverts is ang underground tunnels or pipes carrying water across roads, railways, or other obstacles. Ang cross drains naman is ang small channels or pipes directing water flow across roads or embankments. Ang conduits naman, pipes or channels conveying water, cable, or other utilities. Backfill is ang compacted soil or material filled behind structures or excavations. Ditches, mga shallow, narrow channels for water drainage alongside roads or fields. Ang drains, mga structures or pipes channels directing water away from areas. Ang drainage outlets naman, mga points where collected water is released into water courses, sewers, or natural bodies. So, based on this number 2, any work at pag-prepare sang subgrade, hindi siya allowed nga ma-start unless na lang kung na-approve na siya sang supervising engineer. Okay. So, the finished compacted surface of the subgrade shall conform to the allowable tolerance specified as follows. Okay, permitted variance from design, so above 20 millimeters, or 20 millimeters above. So, level of service, na below 30 millimeters. Permitted surface irregularities measured by 3 meters straight edge, above or below 30 millimeters. Permitted variance from design crossfall of camber, 0.5%. Permitted variance from design longitudinal grade over 25 meters long, na above or 0.1% above or below siya. 0.1%. So, our last topic to be discussed will be the compaction and stabilization. Whether the soil is used as foundation material to support vertical structures, roads, or other structures, it is important to note if the in-place materials possesses the following properties. Number 1, that the soil must have adequate strength. Number 2, the soil must be relatively and incompressible to avoid insignificant future settlement. So when we say insignificant future settlement, ano siya refer sa minimal lang pag-move sang soil or structure over time. Number 3, the soil must be stable against volume change as water content or other factors vary. Number 4, the soil must be durable and safe against deterioration. So when we say deterioration, mo siya pag-breakdown or pag-decay, often gakos na siya nga mag-weaken or mag-disintegrate. Number 5, the soil must possess proper permeability. So when we say permeability, ano siyang ability of a material to allow water or fluids to pass through. Okay, these desirable features could be achieved with compacted fill of selected types of soil properly placed and arranged. Highly desirable characteristics such as strength, low compressibility, and stability is located with high density values as a result of using good materials and proper compaction. So, ini nga mga desirable features, ang mga such as strength, low compressibility, kag stability, kag high density values, resultan siya kuno sa paggamit sang good materials kag pag-compact sakto sang soil. So any type of soil may be used for structural fill provided that it does not contain organic or foreign materials that will decompose or otherwise undergo changes after it is. So any type of soil, magamit mo lang siya as a structural fill. Basta wala lang siya ka-contain organic or foreign materials nga ma-decompose. The water content in the soil fill has substantial effect on its stability and in the process of compaction. Fine-grained silt and clay soil or granular soil containing fine materials are affected by vibrations due to its water content. Soil that is too dry is difficult to compact, and those that are too wet are difficult to spread and compacted. So, ang mga fine-grained silt kuno, clay soil, or granular soil, contain fine materials, kakapektuhan siya sang vibrations tungod sang water content. Kag ang soil nga tam-an naman kuno ka-dry, is difficult siya nga i-compact. Kag ang soil naman nga tam-an kabasa, difficult naman siya i-spread kag i-compact man siya po. So, generally, compacted silt is stable. It is capable of developing fairly good strength and has little tendency for volume change. But silt soil is difficult to compact if wet or if work is performed on rainy period. So generally kuno, ang silt, ang nakompact na nga silt, stable na siya. Tas capable siya sa pag-develop sang good nga strength kag little tendency sa pag-change sang volume. Pero difficult ni kuno i-compact ang silt soil if basa. So, dapat hindi agad mag-compact sang silt soil if kaulan. Kay, mabudlayan kag na siya i-compact if basa siya. So, compacted clay has very low permeability. Diba na, baka naman kagina nga permeability, ability sa material to allow water fluids to pass through. So, ang clay kuno, gamay lang iya nubo iya permeability. Like, ang clay wala siya ability nga mag-allow sang water fluids nga mag-pass through lang. So, advantage na siya kuno. Kaya movement sang water, kaya ma-restrict mo ang pag-move sang water. And, amo man Japon, pares man sang silt, ang clay soils makuno, hindi man siya makompact properly pag wet siya. So, if the height of the fill is reasonably high, marginal materials to be placed underwater should consist of coarse granular materials. Fine-grained soil should be avoided. So, ang granular materials kuno, suitable siya sa mga high fills. So, when we say high fills, amo na mga tall embankments, high foundations, deep underwater constructions, kag heavy structures like bridges and buildings. So, i-avoid mo ang mga fine-grained soil. Ang gamitin mo lang is ang, mga granular materials. If ang height ko na sang fill is reasonably high. So, the thickness of the initial fill should be greater than the normal fill in order to create a working pad capable of supporting equipment used for the subsequent placement and compaction of the fill. So, ang thickness, ang kadamulon ko na sa initial nga fill, dapat mas dako siya kaysa sa normal nga fill para makakreate ko na sang working nga pad nga capable sa pagsuportar sa mga equipment nga gingamit sa subsequent nga placement kag pag-compact sang fill. So, we have equipment for compaction. We have number 1, pneumatic or rubber-tired rollers. The drum-type roller with projecting feet or lugs called the ship's foot roller, vibratory compactors, and smooth drum rollers. So, first, we'll be discussing about the pneumatic tire roller. So, it can be used effectively in all types of soil. It compacts by needing available as self-propelled unit or as towered units. Load sizes vary from 20 tons to 200 tons, of which 50 tons is commonly used. So, ang pneumatic tire roller kuno, suitable siya sa all types ng soil. Tapos, ang iyang compaction method is kneading action. So, when man siya, available siya as self-propelled unit or as towered unit. So, when you say self-propelled, ito move lang siya on its own. Ang towed units naman, attached naman siya sa another vehicle na unit. So, ang iyang load capacity is 20 to 200 tons. So 50 tons ang commonly nga ginagamit. So ang advantage sa pneumatic tire roller is effective siya sa any lang nga soil type. Tapos siya flexible tire pressure adjust to soil condition. So flexible, diba effective siya sa various soil types. So adjust siya, ang flexible tire pressure adjust sa conditions ng soil. Tapos siya suitable man siya for large scale projects. Okay, ang typical applications sini sa pneumatic tire roller is ng highway construction, airport runway construction, large-scale building projects, and earthwork compaction. So next is ang light rollers. So light rollers of 20 tons type can compact 6 inches thick layer with few passes. The 40 to 50 tons roller can compact 12 inches thick layer with 3 to 4 passes. The heavy 200 tons type was proven to compact late. Ito naman na compact. The frequency ranges between 1,500 and 2,500 cycles per minute, that is within the natural frequencies of most soil. So this natural frequency refers to the value at which the soil particles tend to oscillate in unison, giving maximum effect to the repeated impact imposed by the compactor instead of having a random oscillation of particles that would create damping effect, thus shaking the particles into a more compacted arrangement. So, ang smooth drum roller naman has limited depth of compaction. This is not suited for compacting earth fill due to the size of the drum and the large soil contact. This type can be utilized for compacting limited thickness such as granular base course on highways and the like. So, ang smooth drum roller kuno limited na siya ang depth ng compaction. So, hindi siya suitable sa pag-compact sa mga earth fill itungod sa kadakuon sang drum. Sa kadakuon. Sa size sang drum. Kag sa kadakuon sang soil contact. So, the smooth drum roller can be used in earth-moving projects to seal the surface of the fill at the end of each work by providing smooth surface for the water to rapidly run off from the workplace. So, smooth drum roller, magamit mo siya kuno sa mga earth-moving projects para masil ko ang fill at the end of each work day. Kaya provide siya smooth surface para sa water to rapidly run off from the work area. So, may pictures kita de sang apat to. So, compaction equipment should be capable of obtaining compaction requirements without detrimentally affecting the compacted materials. The compacting until may be of any type provided that they are capable of compacting each leaf of material as specified and meet the minimum requirements. So ang compaction equipment dapat capable man siya sa pag-obtain sa requirements ng compaction without na hindi makaapekto sa compacted materials. So, minimum requirements for road roller. So, we have the pneumatic tire roller must have smooth tread tires of equal size that will provide uniform compacting pressure for the full width of the roller and capable of exerting ground pressure of at least 550 kilonewton. So, shift foot tamping as a grid roller should be capable of exerting a force of 45 Newton per millimeter. 250 psi of length of roller. Number 3, vibratory steel wheel roller must have a uniform mass of a tons. The compactor is equipped with amplitude and frequency controls. So number 4, steel wheel roller other than vibratory should be capable of exerting a force not less than 45 Newton per meter of width of the compression roll or rolls. So we have ang table 7.1, soil compaction characteristics and recommended compaction equipment. So we have ang general soil description, arnadang, sand, and sand gravel mixture. So wala siya silt or clay kano. So ang compaction characteristics niya is good. So ang recommended nga compaction equipment para sa sand kag sand gravel mixture, we have the vibratory down roller, vibratory rubber tire or pneumatic tire equipment. So sand or sand gravel with clay, atong kaginan no silt or clay to siya. Wala siya silt kag clay. Sin naman, mera siya clay ni mixed clark. So ang compaction characteristic niya is good. Ang recommended compaction equipment is ang vibratory down roller, vibratory rubber tire, vibratory sheep's foot. So another is silt. Ang iya compaction characteristics is good to poor kuno. So ang recommended na compaction equipment nga gamiton is ang pneumatic tire, vibratory rubber tire, kag vibratory sheep's foot. So wala pa gid. And so on and so forth as sa clay kag sa organic soil. So makita nyo naman na siya. Ang soil compaction characteristic kag ang recommended nga equipment sa pag-compact. So may video kita di sa compaction.
Compaction is one of the construction tasks that takes place on practically every construction project, whether it is densifying fill beneath the slab on the ground or compacting the clay core of an earthen dam. Therefore, it is important that we understand how compaction works, and the good news is that the theory and practice is relatively simple. There are 3 things that we need to know. Firstly, what do we mean by compaction, or what is its definition? 2. How do we execute and monitor the compaction process to ensure that the finished product meets the engineer's specifications? And 3. What is the theory behind soil compaction? To begin, compaction is defined as the increase in soil density due to the expulsion of air, and this is done by mechanical means. Compaction is not to be confused with consolidation, which is the increase in soil density as a result of expulsion of moisture. As we saw earlier, this is a time-dependent process controlled by the permeability of the soil. There are many techniques for compacting soil. Here are some of the more common methods. For coarse-grained soils such as sands and gravels, smooth drum rollers are popular. And for small areas, whacker plates may be used. For fine-grained soils such as clays, sheep's foot rollers or pneumatic rollers are more popular. This equipment is typically effective for relatively shallow lifts of soil, in the order of 250 mm loose lifts. For deeper compaction of coarse-grained soils, an impact roller may be used. These are effective up to depths of approximately 1 meter and have a much higher operating velocity than the smooth drum roller, so they're much more efficient. Even greater depths of compaction can be achieved by using dynamic compaction or vibroflotation techniques. Although these methods have limitations when operating close to existing structures. I encourage you to read the literature and search the internet for additional information and videos on the compaction process. We will now turn our attention towards the theory of compaction. But first, a quick quiz question.
Hello everyone, my name is Fazal. You are watching MFA Civil Engineering. The various type of the earth compaction equipment used for compaction of the earth are smooth wheel rollers, shift foot rollers, and pneumatic tire roller. Smooth wheel rollers are the plain steel rollers, self-propelled type, weighing from 5 to 15 tons, and are used for the ordinary rolling work where deep compaction is not required. The principal application being in a road construction work. These rollers may have one front and two rear wheels. The rear wheels being usually large in diameters and the front one being wider. The weight of the roller can be increased by using a hollow wheels which can be filled with the water or the sand ballast. These rollers are of usually diesel engine type. The plain steel roller compact only the top small thickness of the earth and its effect does not reach the bottom of the layer. The compacting effect is produced primarily by the static weight of the roller. After compaction, the roller leaves a smooth surface. As the roller is pulled forward, a wave of the soil is pushed up in the direction of the movement, and with the successive passage over the ground, surface soil is gradually compacted. These rollers are effective in the compacting a granular soil like sand, gravels, and crushed stone. For compacting earthwork in an embankment and the canals where deep compaction of the earth is required, shift foot rollers are used. Shift foot rollers are of three types like ordinary shift foot roller, convertible roller, and turn foot roller. Ordinary shift foot rollers produce a good compaction throughout the thickness of the layer when the soil is clay or predominantly cohesive and impervious. The roller consists of the hollow steel drum and have projected feet or projections mounted on the surface, which are arranged around the wheel at 100 to 200 mm center to center along the axis. These stamping rollers may be constructed as a self-propelled or as a tow unit. The shift foot rollers may weigh up to 15 tons or more and travel at a speed of 25 km per hour using a wheel tractor for towing. As the roller moves over the surface, the feet penetrate the soil to produce a kneading actions and a pressure to mix and compact the soil from the bottom to top layer. With repeated passage of the rollers, the penetration of the feet decrease. In the convertible rollers, there is a plain drum to which curved plate having a welded shift foot are attached. When these detachable plates are removed, the drum can be easily rolled to the side. In case of a turn foot rollers, the shape of the individual shift foot can be changed, thus varying the pressure on the soil. A common type of the pneumatic tire roller consists of a base or platform mounted between the two axles, the rear of which has one or more wheels than the front one. The tires must be so arranged that the track of the forward wheels lies in between the track of the backward wheel. The pneumatic tire rollers are the most suitable for compacting a fine-grained soil and well-graded sand. The machine is self-propelled and ballasting is done using either water, sand, or pig iron to increase the self-weight. The major advantages are the ability to control the ground contact pressure by altering the weight of the machine, increasing the number of the wheels, increasing the tire width, and changing the contact area of the tires by altering the contact pressure.
So that would be all. Thank you.